Hi, everyone. Welcome back to Altium's OnTrack podcast. This is Judy Warner. Today we have a special guest that I'm eager for you to meet. But before we get going, I'd like to make sure that you subscribe to our podcast and favorite us on your favorite RSS feed. You can follow me personally on LinkedIn, which I would love, or on Twitter at Altium Judy. And Altium is also on Facebook, Twitter, and LinkedIn. So today we have a young rock star of engineering with us named Jeremy Blum. And I'm going to read a little bit, so forgive me while my eyes leave the screen for a moment. He's got a lot. There's a lot there with Jeremy. So on his website it says this: my passion is using engineering to improve people's lives and giving people the tools they need to do the same. Jeremy is currently the head of electrical engineering at Shaper, where they're using computer vision to reinvent the way people use handheld power tools. Prior to joining Shaper, he was a lead electrical architect for confidential products at Google X, including Google Glass. He has his master's and bachelor's degree in electrical and computer engineering from Cornell University. He did a lot of amazing things at Cornell, and he has an insatiable passion for building things: prosthetic hands, fiber optic LED lighting systems, 3D printers and scanners, on and on. And some of his work has been featured not only in international conferences and peer-reviewed journal, but in also popular media outlets such as the Discovery Channel, Wall Street Journal, and Popular Science magazine. He was also named Forbes magazine 30 Under 30 as recognition in his work that has helped America make things and get stuff done. He also holds several patents. He loves to teach. He has a YouTube channel with lots of video tutorials, and his latest, I guess, I don't know if it's your latest, but he's written a book called Exploring Arduino, but he spends most of his time investing his talents and time at Shaper. So, Jeremy, welcome. That was a mouthful. So
thanks for having me.
Yeah, so you're awfully young to have such a pedigree. So I want to ask you first, after watching a few of your YouTube things since they go way back, I noticed a couple t-shirts you had worn in those that said you were a geek. But my first kind of tongue-in-cheek question is, are you a geek or are you a nerd?
I think geek is the cool term now.
I think so too.
I go with geek, I think. Although, if we're being totally honest, I'm also a nerd, right? If you consider a nerd to be the person who's really into reading into like super in-depth topics and getting really in the weeds and stuff, I'm definitely that too. So I'm kind of guilty of all the above.
I would concur with that. And I think geek's like a cool term now. It used to be the uncool term. Like now, nerd seems like but nerds are like Sheldon Cooper, like physics, chemistry, right? Book smart guys.
Yeah.
So tell us a little bit what your earliest memories were of sort of making and building things. I mean, most people like you remember some pretty vivid memories of taking apart home appliances or putting stuff together.
Mm-hmm. Yeah, so, it makes a very perfect circle of my life, if you will, and that some of my earliest memories of building things are woodworking, and now I work at a company making woodworking tools. But some of the early memories I have are my dad and his dad are fairly experienced woodworkers, so it was spending a lot of time in the garage at home building stuff with him. I went to summer camp where they gave you all these outdoor activities and things you can do, water skiing and hiking and all this stuff, but I ended up spending as much time as they would allow me to in the woodworking bunk, which was this little, basically 8-foot by 8-foot room with a couple of tools that, I feel like they wouldn't let kids do this nowadays, but at least when I was 12, they let us use jigsaws and bandsaws and stuff like that. And I feel like the liability issue is different. Like, it's changed in the last decade or two. But when I was 10 or 12, that's what I was doing. And I was building furniture that was admittedly not great, but I think pretty good for like an 11-year-old.
Right.
And so those are some of my earliest memories. Before that, the same thing you'll hear from most engineers, right, which is Legos and Connects and things along those lines, taking apart stuff in my parents' house and totally failing to get it working again after I've taken it apart. After I did that a couple of times, I learned my lesson a little bit and got a little bit better about keeping track of what screws go where so I could put it back together. But I've been taking things apart and building stuff for as long as I can remember. It started more on the mechanical side of things and has transitioned towards the electrical and electromechanical and robotic side of things as I've gotten older.
I saw a comment you wrote on your personal website that said you felt that engineering was sort of along the same lines as artistry. What did you mean by that exactly?
I think people use art to express themselves and to leave some kind of impact on the world around them, convey an idea, convey a concept. And I don't really think engineering is any different than that. It's a lot more based in equations and math and physics. But at the end of the day, you're still kind of taking some input, some desire that you have and trying to generate an output that'll have some kind of impact on people, right? So whether you're building a spaceship or a car or some little doodad or trinket, the goal at the end of the day is you want to be able to give it to someone or show it to someone and have some kind of impact on them and affect the way they think or work in some way. And similar to art, in my opinion.
It's funny that they've kind of come out with this new acronym, right? That was STEM, and now it's STEAM, right? Because they've added art. They're starting, I think the thinking's starting to change of how close. I was raised by an artist, and so I've always had that bug, but I like, you and I were just geeking out about the Falcon Heavy launching, I'm just as happy, I'm thrilled as much sort of being in the work I am with technology as I am with art. So I think there really is a connection there. So
I'm a big fan of that acronym change. I think it does a really good job of bridging the divide. STEM was it felt like this other thing, and you were like an artist or you were in a STEM field. Yeah. And that's not the case. There's so much overlap. I work with designers and everything every day, and I couldn't do my job without them. So
well, I can tell you that for me, I'm a little bit more of a creative person. I write a lot and express myself through writing and speaking, communication, but I was horrible at math. But I loved making things, and I took things apart. But just because I didn't have that aptitude for math or it wasn't encouraged, it made me feel like I was in no man's land. So for me personally, I'm with you. I like that it's sort of crossing over because I'm like, I am sort of in this, I'm like, why have I spent the last 30 years, in circuit boards and, how did I get here? But I think it is that connection and that curiosity, right? So, we'll get up to talking about Shaper, which is really what I wanted to talk to you mostly about today. But I wanted to also mention that when you were very young, you started this YouTube channel. And you've recorded an awful lot of educational videos and really helpful stuff for makers, hackers, and different people that have sort of used that as a jumping off place and inspiration. So what inspired you to do that in the first place?
In the first place, so I think the very first video I published was me building a computer, and it was my first experience building a computer. I didn't really know what I was doing. And I just thought it was really cool, and I wanted to make a video of it, and my friends and I were already hobbyist videographers. We really liked making short movies, like kids make short movies, action movies, things like that. But we had already developed that into a business, and so we'd gotten pretty good at it. When I was 12 or 13, a friend of mine and I from high school started our first business, which was doing video production, and it was pretty successful for like weddings and birthday parties, video montages. things like that. Now you can like press one button on your MacBook and it'll do it for you. But we lived in this golden age where people hadn't figured that out yet, so we could do it as 12-year-olds and charge money for it.
And by the way, the 12-year-olds are were the sharpest people in the room. I mean, I still ask my 20-something kids, like, my phone's not working. You know, you guys really had an affinity, and like you said, there's more than one button. We're like, but it was really the rise of technology, and you were kind of right in the middle of that, I suppose.
Yeah, the timing was really good. YouTube had kind of just come into existence when I was building that first computer, and we had experience making videos, but they were mostly, you know, pictures of other people for their weddings and things like that. And so we wanted to do something we were passionate about. So a friend and I, we were going to build this computer anyway. We filmed it. We set it to music. People seemed really into it and then started asking us lots of questions like, oh, how did you pick this? How did you do that? And it just kind of grew from there, and people seemed really into learning it and appreciative and positive. You hear all about all the terrible things that people say on YouTube comments and stuff, but it was all positive. And people were appreciating it, and so I liked being able to help people, and so it snowballed from there.
That's so nice. There's your creativity again, right? The crossover of your creativity and your scientific self. So do you still keep that website up, or are you pretty much tied up with the startup work you have at Shaper now?
I've been pretty damn busy at Shaper. You know, if I could, I'd love to put up a YouTube video every week. The reality is in terms of my YouTube stuff, I'm a one-man show. I do all the writing. A lot of those videos involve me developing projects and all the documentation around them and a lot of open source stuff. You know, a 10 or 15-minute video takes me, you know, many dozens or more hours to produce because I'm such a perfectionist. Like, if I was less of a perfectionist and I could make just kind of slightly crappier but still informative videos, I would do it, but I have trouble putting out something that doesn't have high production value. So I'd love to make more videos, and I hope to get back to doing more of them, but I will admit the frequency of my postings has dropped off considerably, especially in the last 2.5 years or so that I've been at Shaper, because I've been so focused here.
Yeah. Okay, well, it looks like you still have like 160,000 subscribers and a whole bunch. So it looks like people are still engaging with your stuff, even if you're not keeping up with it. So,
oh yeah, they do.
Kudos to you. So you did your bachelor's and master's at Cornell, and what was your first job when you got out of school?
There's kind of a bunch of different ways I can answer that, because I had a bunch of jobs while I was in school, and I was also working on my own stuff, overlapping with a lot of that. My first real full-time job, I guess, was at Google after I finished my master's degree. But before that, I had a startup that I was working on for a while that ended up petering out. And before that, I worked at MakerBot, the 3D printing company, for a few years, first as an intern, and then I consulted for them remotely while I was in school, working on their electrical stuff. But my first full-time job was at Google X, yeah.
So what kind of things did you work on Google that you wouldn't have to kill us to tell us?
Most of it's pretty out there now, so I can talk about most of it now. Not all of it, but most of it. The majority of my time there was spent working on the electrical engineering and system architecture for what became Google Glass Enterprise Edition. So there was the first version of Google Glass that came out to consumers, and I won't spend the time going into all the social implications of that product and the things that were done poorly or things that were done well. But my focus was on what became the Enterprise Edition of the product, which is totally new hardware and is used by a variety of very large companies and medical practices around the country now as an augmented reality platform for basically helping with productivity. So that's a piece of hardware that's basically an upgraded version of Google Glass from what most people saw.
Right.
All new processor and everything inside of everything's new and different. But that's used by big companies like, I think, Boeing uses it in their assembly line to do cable assemblies, things that they used to have to look at a manual. They now see heads up and they get feedback as they're doing it, and they like cut their assembly time in half. There's a bunch of startups building software on top of the enterprise version of Glass now. for medical applications. So doctors use it in their patient interactions to pull up medical records and things like that in real time and make them more efficient and more productive. And there's a bunch of other applications as well. Those kinds of applications are the things that originally got me excited about going into work on that project. Don't get me wrong, I have several pairs of glass. I don't really wear them anymore, but there was a period where I wore them almost every day and used them for all the mundane things that they showed in the original marketing videos, like sending text messages and getting turn-by-turn navigation and stuff. And they were cool for that, but the applications that they ended up developing for the enterprise edition of it, I think, are where an augmented reality platform really shines. So I'm proud to have worked on that.
That sounds like a pretty exciting project and company to work for, pretty much fresh out of a master's program. So that's exciting. So how did you go from Google to Shaper? And then let's start talking about Shaper, because I've seen some of the videos and I want to run out. I want one. I want to go build some stuff. So tell us about that transition, and then start filling our listeners in about this incredible new handheld CNC you guys have developed.
Yeah, happily. So when I was at Google, one of my tasks, in addition to kind of leading the system architecture for some of the products we were working on, but in addition to those responsibilities, one of the other things I did there was kind of to always be scouting for external technologies that might be relevant partners for things that we're doing, things in the computer vision space, things like that. So I'd go to a lot of conferences for this, and me and my colleague from Google, Joe is now the CEO at Shaper, me and Joe went to this conference called SolidCon in San Francisco, where we met Alec, who is one of the two co-founders of what is now Shaper. At the time, it was still called something else. And so we went to this conference, and Joe and I walked out, and we're like, everything in there was like, but man, did you see that one booth, that auto-correcting hand tool thing? That thing was so cool. And so one thing leads to another. Joe ends up leaving Google and going to what is now Shaper to become the CEO, to join Alec and Alon, who are the two co-founders. And shortly after Joe left, I also left to come over to Shaper to lead up the electrical engineering efforts here, and to basically be responsible for taking a prototyped product that was not manufacturable at all, and making it into a manufacturable piece of hardware that we could mass produce and sell to people at a reasonable price that would perform well and be reliable and all the things that you want a power tool to do.
Right.
So let me now explain what Shaper is. So Shaper is a handheld robotics company. We like to call ourselves a human-in-the-loop robotics company. And our first product, Shaper Origin, just started shipping to customers about 3 or 4 months ago.
Uh-huh.
And so Shaper Origin is a handheld CNC. And for listeners who aren't familiar with CNC, or computer numerical control, CNC machines are what you can imagine a company like IKEA might use to mass produce furniture. So they can range anywhere from desktop size for several $1,000s to the size of a warehouse, basically, going up to millions of dollars. And the way a CNC machine works is you say, I want to cut X design, you throw in some sheet material, normally plywood, and you pre-program all the paths that a cutting bit is going to take, and it moves around and cuts out this material. So CNC machining is basically the opposite of 3D printing. 3D printing is an additive manufacturing technology. CNC machining is a subtractive technology. You start with the material, you cut stuff away until you have the solid item that you want in the right shape. So what Shaper Origin is it takes that concept and basically shrinks it down to an affordable, portable, handheld power tool. So we're trying to bridge the gap between the capabilities of what you can do with hand tools and the capabilities of what you can do with, multi-tens of thousands of dollar CNC machines, mm-hmm. and pick something kind of in the middle, right, that gives you a lot of versatility and capability. So the way Origin works is it's computer vision based. We use computer vision and real-time motor control to basically scan your workpiece. We have this stuff called Shaper tape. You put it down on whatever it is you're going to cut. It can be a piece of sheet material like you would cut in a CNC machine, or it can be an already fully built table that you want to make a particular feature in. Maybe you want to put a mother of pearl inlay in it or something.
Okay.
You put your tape down on whatever you're going to cut, you scan it in. The tool now knows, based on tracking with computer vision off of those markers, exactly where it is in 3D space. You load in a design file, the tool is connected to Wi-Fi or there's a USB port, so you can make your design, and we're totally CAD agnostic. You can make it in any 2D or 3D CAD program you want.
Yeah, so like AutoCAD, like what kind of tools?
Anything. In the 3D realm, the most common tool that our users use is Fusion 360.
Okay.
But in the 2D world, the most common is Inkscape or Adobe Illustrator. Really anything that can generate an SVG or a vector file format.
Oh, okay.
And so you can do some color coding of that design in advance to instruct the tool how you want to cut it, or you can do it all in the tool. But basically, the gist is you make your design in advance, you get it to the tool, it flies over magically via Wi-Fi, you put the design in your account online, it just appears on the tool. You click the design, you move the tool around your workpiece like a cursor, click to lock the design to the workpiece, and now that design is like virtually locked to wherever you chose on your workpiece. And at this point, it's like a video game. The screen is a capacitive, 5-inch capacitive multi-touch screen. You move the tool around the workpiece. The tool is basically autocorrect for your hands. So there's a corrective region on the tool. There's motors that compensate for your movements in real time. So you do the rough cuts, and the machine does the precision adjustments for you in real time.
See, when I was watching it, you could see the image on the screen, like you were following a pattern. Say you were cutting out a rectangle, and it was... So I was trying to get my head around, wonder if you slipped, or like, to me, the human was the problem in that equation. So after you do the rough cut, do you just, like, how do you literally handle it?
It all happens live at the same time.
So okay, I gotcha.
So like, let's say you want to cut a perfect square. You cut mostly a perfect square, but you're a human, so you're moving back and forth. You're making micro adjustments as you go. You're shaking back and forth, whatever. It doesn't matter. Yeah. Any movement that you do that's contrary to the design that you've placed on the tool virtually is compensated for in real time. So if you want to cut a perfectly straight line and you're moving in a zigzag, you get a perfectly straight line because the tool is moving opposite to your zigzag direction in real time.
That's incredible.
So what you end up with is a cut that looks like it came off of a $10,000 or $100,000 CNC machine that might take up an entire room.
Right.
Out of a handheld tool that, when you're done with it, you put it back on the shelf. So it opens up a tremendous amount of possibility. CNC machine, you work with sheet goods. With our tool, you can work on any existing work surface you have. You can, inlay designs into your existing wooden floors. You can go to your kitchen countertop installation and cut out the opening for your sink without any jigs or fixtures or really thinking about it at all in advance. And most of these things you can even do without ever involving a computer in the process, because we have on-tool design capabilities as well. So you can design things directly on the tool, lock them to your workpiece, and then automatically do those cuts. Yeah.
So what kind of materials? Like, obviously wood, say plastics. What kind of other types of materials can it work on?
Yeah, so at the heart of Origin is a 720 watt trim router motor. And so you can really cut anything that you would cut with that. We do hardwood, softwood, plastics, composites, soft metals like aluminum and brass. We've done a fair share of jewelry, dog tags, things like that with the tool. We've done composites, corian, like countertop material. We've done soapstone. Really, anything that you can imagine cutting with a traditional router, you can cut with Origin. We're not changing the physics of cutting. We're just making it a lot easier, and we're guaranteeing that you get a high quality cut with a handheld tool, basically regardless of experience level.
which is so great. Like, I've always thought it'd be so great to work with wood, but I know the learning curve I'd go through, like, would totally discourage me. But when I saw that, I think it was a recent video that came out, basically creating an outdoor chessboard on it looked like a tree stump, right? The kind you could lose in the park. I think that's what it was anyways. And cutting out each square and then laying it with the darker wood. And it was stunning. And I was watching the screen and just this interactive thing. I was like, I think I could do that with a little training,
You don't even need a little training. You could just do it. And that project, by the way, was done entirely with on-tool design capabilities. So no computer was ever involved in doing that. They literally got a slab of wood, said, we want to make a chessboard. The tool, because it knows exactly where it is in the scale of everything, you can lock a grid to whatever you're going to do. So it locks a grid to it. Say, I want a 1 by 1 inch square grid. Say I want to cut out every other square to put an inlay in for my chessboard, and you're done. And the learning curve on it, and you don't have to take my word for it if you go to the Shaper Tools Instagram or anything like that, or if you search Shaper Made on Instagram, there's a lot of people getting them and unboxing them. And you can watch this. It's a pretty funny progression. Someone just posted a video on Instagram yesterday where they're like, oh my God, I got Shaper Origin. And 30 seconds later, they're like, oh my God, I'm opening the box to Shaper Origin. And then 30 seconds later, they're like, I'm doing my first cut with Shaper Origin. 30 seconds later, they're like, I already figured it out. This thing is so easy. Like, I don't believe how easy it was for me to figure out how to do this. And that's part of what we're trying to accomplish.
Well, I love that, and I can't wait to see. I'm sure you guys are excited to see, too, because I'm sure your imaginations have run wild with what you can do with it. But once you start shipping it and getting it in people's hands, what they're going to come up with is going to be phenomenal, right?
Oh, yeah.
Like,
absolutely. And we've been beta testing various versions of the prototype of this product for going on 2 years now, more than 2 years, I think. So we have a lot of data about how people use and abuse this tool. And we've tried to design all of those workflows and eventualities into it, but people continue to surprise us every day. Especially,
that's funny.
Now that we're shipping out so many of them, people do things you would never think of, and it's great, and they love it.
It's so fun. Well, like I was just saying, for me personally, woodworking, that sounds fun. The barrier would be like, learning curve. The other barrier is good lumber, teaks, they're expensive, so you don't want to screw them up, right? So sure, I would think that to sort of have this sort of foolproof, once you've learned it, to feel really confident going to buy a really beautiful piece of wood, I think that would take away that sort of barrier to entry, right, for people to try it
absolutely.
as well.
Yeah, you try it out for a couple minutes, you pretty much get the hang of it, and then you feel pretty confident. I mean, to give you context, I think one of my coworkers is doing a test today where he's over at some guy's house doing straight up inlays into a wooden floor, right? So
that's brave.
There's no room for a mistake there.
Yeah, right.
And this is not the first time we've done that. In fact, there's a bunch of patches on the floor in our office here. We're in a pretty old building in the Mission District in San Francisco, and the wooden floors here have seen better days. We ripped up carpet when we moved into this office, and the wooden floors were not in good shape. And we found all the holes. We did live inlays for them and patched them up, and it looks great.
That's so cool. So, you said you just started shipping how long ago?
So the first units started shipping out in October.
Yeah, so what's the feedback you're getting from these early shipments?
I mean, it's great. People are getting them and using them and doing all kinds of amazing projects, and they're posting them online. And we have a forum on our website where there's a lot of people posting projects, but also lots of people post on Instagram and Twitter and Facebook and have been sharing what they're doing. And it's been very exciting, nerve-wracking, and exciting experience to see people getting this tool in their hands finally that we've been working on really hard now for several years. The anticipation, we started doing pre-orders for the tool at the end of 2016. So a lot of these people have been waiting for well over a year to receive this product that they, put their faith in. We told them, we're going to make this. Here's the pedigree of the team. We know what we're doing. We know how to make stuff. But still, as with any pre-order, we didn't use Kickstarter, but anything similar to that, it's some amount of risk to anyone. So people now receiving it and getting them and saying, wow, the build quality is excellent and this thing works exactly the way you said it is and it's intuitive. It's very heartening to see that.
That's so great. So what is next? So you're shipping Origin. I'm sure you have some things in your back pocket, perhaps, that your, future dreams for your next iterations or other types of tools. Don't tell your secrets. I'm not asking your secrets now. No IP spoiling.
We've got lots of things that we're excited about for the future. The key focus right now is we're still catching up to pre-orders, right? So we've been ramping up our manufacturing capability and are just now kind of getting up to full speed, the maximum output that we can expect from our factory. And it's still going to be a little while before we finish fulfilling those pre-orders, especially since more and more orders come in every day, and so we have to keep adding more and more that we're going to be manufacturing. So that's my key focus right now.
Yeah.
Is making sure that goes smoothly, and we're generating a high quality product that meets a lot of very exacting quality standards. I mean, we really are building a precisely calibrated and sophisticated, basically industrial robot that we are selling as a consumer electronic device. And so making sure that everyone that comes off the line is identical and works the same way, and we know exactly how it's going to behave and it's going to work with the accuracy and precision that we've promised is a big focus right now.
Yeah.
So that's what we're focused on, and there'll be more things in the future from us too.
Now, one reason we became acquainted with you, Jeremy, is we know, with every startup you have to wear multiple hats, and it sounds like you're wearing multiple hats. But one of the hats you've been wearing is as an electrical engineer, which is electrical engineers and PCB designers will be the bulk of our listeners here. So can you give us a little insight sort of to that, your electrical design and I know that you've been using Altium, and I know you've used some other tools in your lifetime, but I know you're using Altium now. So tell us a little bit about what's under the hood and what it took to get Origin running and sound from an electronic standpoint.
Sure. Yeah, absolutely. I mean, I'll leave some of the exact details of what's under the hood until someone out in the wild does the inevitable teardown of the product, which
okay.
I don't think anyone's done yet, but I'm sure that will happen soon enough. So I would say to look out for that.
Okay.
But so we used Altium for all the design of the rigid and flex PCBs inside the product, of which there are many. Like I mentioned, since it is effectively an industrial robot, the electromechanical requirements of the tool and where the physical electronics are for different things is complicated. So it's a large multi-board system. Mm-hmm. There's the camera that's used for viewing the workpiece. There's the capacitive multi-touch display. There's the application processor and the microcontroller that's responsible for all the motor controls. There's the boards that are out controlling the correction motors and the Z-axis motor that moves the actual cutting bit up and down. There's a sensor in the base that's used to do Z touch off so that the bit knows where it is in space. So there's a lot of boards in there, boards and flexes, all designed with Altium. One of the things that, and as you mentioned, I've used many ECAD packages in the past, basically any major one that you can think of. And one of the first things that I was tasked with when I came to join Shaper is there was no real electrical or formal electrical design before I was here. There were prototypes and one-off boards that were used to simulate and test certain aspects of the design, but the whole architecture has been new over the last 2 or 3 years since I've been here to make the product manufacturable. Mm-hmm. So the first thing I was tasked with was I had to decide, okay, in the past I've mostly been dictated to for one reason or another, here's the CAD package you have to use. And I'll say something that was difficult for me at Google is I I was working in Altium for some of our work, and then for reasons that I won't go into, had to use a competitor product to Altium's and did not enjoy the experience. So it was a pretty easy choice when I came here, but one of the driving factors of that was we're a very lean team here, as you said. I'm responsible for a lot more than just the electrical engineering and the PCB design. And so the 3D capabilities of Altium have been super important. We have really tight tolerances inside of this product, and we have to meet a lot of requirements because it's robot, and we want things to fit together perfectly to make sure that it's performing the way we expect it to. So a lot of that ends up playing back down to the PCBs and understanding exactly how much space they're going to take up and exactly where every component is and how big it is and which things are touching off to thermal pads or which things are going to have a certain amount of clearance. There's AC power that comes in from the wall. We have to meet certain clearance requirements and make sure those distances, not just in 2D but in 3D, are also correct and acceptable to ship this product. So the 3D capabilities of Altium have been incredibly useful. Actually, with the new release of Altium 18, I just started playing with the multi-board assembly feature, which has already been very useful for some of our rigid and flex assemblies that go together. And seeing how those fit together has been super useful and a really important part of my job, and makes it faster to go from an idea to making something that we know fits and we can build into the mechanical CAD model of the tool and know that everything is going to assemble together the way that we expect it to and designed it to.
Well, and looking at Shaper Origin, it does have a really, for all the capability that it has, you know, it's really doesn't appear to be terribly larger than a typical hand router. You know what I'm saying? Like, but has so much more capability, so there's got to be a lot crammed inside, you know, and including, like you said, the display and the sensors and all of this. So it kind of reminds me, actually, what I imagine in my mind coming from the board industry is like drones, where you have to fold everything up, you know, and fit it mechanically, you know, size, weight, and power. That's the mantra, you know, in military, size, weight, and power, to keep things in that really tight but super functional footprint and be able to stand, you know, the thermal stresses of being in a small package and the vibration and all these other things. So I'm sure it was not an easy design or set of designs.
You know, we're a startup, we're lean, small team of engineers here doing this. So we've built a lot of our own testing equipment and fixtures to stress test this machine. So it's working in a dusty environment. We wanted to know, is this machine going to be test proof? Okay, so we used Shaper Origin to build a dust chamber for itself.
That's fun.
Hooked up an air compressor to it. There's videos of this online. Blast it with talcum powder and sawdust for, you know, run it for days straight with all the motors cycling, run them through that, analyze different configurations of our Z-axis assembly and how the PCBs are sealed and things like that to protect them. And so we've done all that. Same thing goes for our spindle motor and building systems to test the functionality and lifetime of that. All things that we've developed in-house to make sure that the design works the way we expect it to and is going to stand the test of time and be a reliable tool that you can use in your shop for many years.
Well, it sounds like wonderfully brutal work that you've done the last couple of years. Really rigorous engineering standpoint. Now, where are you manufacturing it? Both, you know, short term and long term. I don't mean to say that in a loaded way, but are you manufacturing it now locally and in-house? Are you contracting out? I mean, how will you handle the manufacturing challenges over time?
Well, so Origin, like basically any product that you buy today, is a global product. So to say that almost anything you buy is quote unquote made anywhere is already sort of deceptive, because parts come from all over the world.
This is true.
PCBs come from one country. Our spindle motor comes from Germany. Extrusions and plastic parts come from another country. The final assembly currently happens in the United States. I won't go into more detail than that, but
Yeah.
That's the final assembly phase, and you'll see on most products now, if you really dig into it, they're kind of made everywhere.
They really are. It's a really good
there's not
answer.
Any other way to do it.
No,
Yeah.
and it really is a global economy, and that's never more true than electronics, because we source our parts from all over. So, yeah,
Absolutely.
and when you're in the startup scrappy mode, especially, right? You have to be able to get it to market, affordably and reliably, and do all these things. Well, thank you so much, Jeremy. I have really enjoyed this conversation, especially the part about the electronics. And we love supporting startups here, and I hope soon we'll come up and shoot a video, at your plant and be able to show our audience some of the neat things you've been able to do with our tool to make your tool. And we love that we support companies like Shaper and engineers and designers like you. It's what wakes us up in the morning. So thank you so much for telling the story.
Yeah, my pleasure. Shaper and Altium have a lot in common. We're both making tools to help other people make things.
Exactly. That's what we do. We wake up in the morning, and that story of Altium started from its very beginnings, from a couple of university students, that were teaching, and they thought the young, hungry, startup-minded population should have tools. And at that time, they weren't available. They were mini computers, and they were large, expensive engineering stations, and they weren't available. And so our two scrappy founders said, heck with that. We need tools. And so they just started making them on a PC and haven't looked back since. So that spirit still kind of lives in our building. And I think, that's what people kind of still relate to that spirit. We do we do share that in common. So my last question is, and I hate to ask this of you because you work so much. I'm sure you don't have any spare time, but I have noticed, because of the overlap of arts and technology, a lot of people I know that are designers, engineers, usually have really incredible hobbies like woodworking or painting or music, or some kind of really interesting hobby life. And so I always like to ask at the end of this program, I call it Designer After Hours. And so I want to ask you what you do after hours, but I'm worried you don't have any hours after hours right now.
It seems like fewer and fewer every day, but I do still try to make time to work on personal projects. And I have the great fortune of working in a fully featured wood shop, so that is definitely some of what I do. A lot of things in my apartment are made in the wood shop here, mostly using Shape Origin. So various pieces of furniture in my apartment, and game boards, Chinese checkers set, organizers for my kitchen, simple things like that, but just fun projects. And when I'm not doing that stuff, for me, my hobbies are the same. I'm very fortunate that I really like things I work on, so my hobbies are the same things I work on. But when I'm not working on the electronics for Shape Origin, I do other software and electronics projects. I document them on my website and on GitHub and on other places. The thing that's been a recent area of interest for me has been home automation, and this has kind of just been an ongoing project for me for the last couple of years, building a natural language voice-controlled home automation system. So something along the lines of how Amazon Echo works. The first version that I built, just so we get the record straight, was working long before Amazon Alexa came out. I will cede in saying that the current products manufactured by Amazon and Google are way better than anything I've made. But still a fun learning process, and it is a system I use in my house every day. It's a natural language voice-controlled system that I have hooked into my lights and my music, and I had hooked into the shades in my old apartment, but not anymore. And I have it hooked into my phone, and the number one most used feature is because it's still like kind of weird to talk to an imaginary computer thing to ask it to do stuff.
I know.
And so I still don't feel super great about that, but I do it because it's an interesting engineering problem. It was interesting to learn how to write those natural language processing software. So I've been doing a bunch of that. But my most used feature is still just like at night when I'm ready to go to bed, I have my phone, I just like give it a shake and it turns off all my lights.
Oh.
And it's so simple, but that's, stuff like that.
I want one.
What I do.
I want one. I have 2 Echoes in my house and still am not using them for half the stuff that they could do, but they are super fun. Well, again, thank you, Jeremy. It's been great to have you and so great to learn about Shaper. Give us your website real quick, and then we'll share some links below with our audience. But give us it real quick, just the website.
Yeah, if you want to learn more about Shaper, go to shapertools.com or just Google Shaper Origin on Google. And there's a ton of YouTube videos, lots to see what the tool is capable of. And if you want to know more about what I'm doing, I'm at jeremyblum.com.
Very good. Jeremy, thanks so much. You're really fun to watch, and we'll keep our eyes on you and keep our eyes on Shaper, and we'll look forward to talking to you soon.
Thanks a lot.
Thank you. This has been Judy Warner with the Altium OnTrack podcast. Thank you for joining us with our talk with Jeremy Blum. Please remember to subscribe, and we will see you next time. And remember to always stay on track.